Let's do quadratic formula just as an introduction today, and then next time you're going to see that even though it seems scary at first, it's actually the easiest way to solve these problems. And I'm going to pick one that we've already done just for balance's sake. So x squared plus x minus 12. And I'm going to step through it the first time, so you don't have to just guess at what you're doing. So we have, I'll go to your color. This is, I'll actually pick this to put our formula down. This is the big thing that gives some math students nightmares. X equals negative b plus or minus the square root b squared minus 4ac over 2a. It's pretty ugly, right?
Yeah.
But when you sing it along to the melody of Pop Goes the Weasel, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a little friendlier now, huh?
Yeah.
It's a lot easier to remember. I like literally until I was like 20 and like in college, every time I had to use this, I was singing that in my head as I wrote it down. It's also why we don't teach the alphabet just like A, B, C. There's like a song to it, so it's easy to remember. Anyway, so it's really not that scary. And all these A's and B's and C's mean, it's just the numbers that come in front of these three terms. C being, it's whatever number shows up that's not in X. We call them coefficients. They're the numbers in front of the X's. And this problem is really easy because what's the number in front of X squared?
0.
It's not quite 0. You have 1 X squared, right? You don't have 0 X squareds, but you have 1 X squared. What's the number in front of just X?
1.
1 as well. And then what's the number, what is C? What is this whole term? C is negative 12. You've done most of the work already. Now you take those three values, and everything here is either a symbol or a variable that you're about to plug in for. So really plugging into this isn't terrible. It just starts to tell you your answers right away. So negative b being negative 1 plus or minus
1 squared.
1 squared. So you already got the pop wheat goes the weasel in your head. Minus 4, what's a? 1 times c. Negative 12, that's a little trickier, that's okay. All over 2 times 1. 90% of the problems you'll see, A will be 1. Almost always. If it's not, then factoring becomes really hard because we solved this problem by factoring. Yeah, we solved for the zeros. You can factor a good amount of these types of equations. But for the ones that aren't factorable, like there's no perfect number that multiplies to this and adds to this, then this is just your fallback. This is the answer. This will give you the answer every single time, no matter what. It's a little messier, not quite as fast, but you'll always get the right answers, and we'll see that here once we crunch these numbers. So let's do it. X equals, it's negative 1. Yeah, when I say plus or minus, I'm actually meaning there's going to be 2 answers. One will be a plus, one will be a minus. What's 1 squared?
2. 1.
1, right? What's 1 times 1? 1. All right, here we go. Negative 4 times 1.
Negative 4.
Yep, and then what's negative 4 times negative 12?
48.
48. And is that going to be a plus or a minus?
Minus. Plus.
How many negatives are we multiplying by here?
Oh, it's plus.
It's a plus in this case, right? We have negative 4 times negative 12. So the number will be whatever 4 times 12 is. And the sign is a double negative, aka a positive. I sometimes even think of these as 2 negative signs like smashed together and one kind of like tilted or whatever. Or they like ran into each other and each bent into like little L's. Anyway. All right, and that's all over 2a, or just 2 times 1.
Oh, 2.
We good with that? All right, what's 1 plus 49?
You said what's 1 plus 1?
Let me just give you the answer right away.
49.
Okay, what's 1 plus 48? There we go. Negative 1 plus or minus the square root of 49 all over 2. We're actually almost there. we are going to do -1 plus this number divided by 2. And then we're going to do a second answer, which is -1 minus this number, all divided by 2.
Oh, I remember this.
Do you know what the square root of 49 is?
No idea.
It's whatever number.
7.
7, okay. That's all I had to say. It's whatever number. You're like, oh, it's 7, clearly. All right, so x equals -1 plus or minus 7 all over 2, which, like I just said, is actually just two equations. It's x equals -1 plus 7 over 2, and it's x equals -1 minus 7 over 2. When I say plus or minus, I literally mean plus or minus. So let me just do one of these really quick because we just ran out of space, but I've got the magic here. It's going to get that little red box up there too, but that's fine. That works. Okay. So let's start with this one here. What is -1 plus 7?
6 divided by 2 is 3.
And then what is -1 minus 7?
Negative. -6.
That would be -7 plus 1. And let me just do this for you really quick. Here's 0, -1, -2, -3, -7, -8. So here's -2, -4, 6, -8, and so on. So we're going to go to -1 right here. Now we're going to move back 7. -8, right? Negative minus, when you have a negative and you're minusing something, it's like adding. It's just adding into the negative direction.
Yeah.
All right, so anyway, -8 over 2. So what is our other x answer?
-4.
-4. Cool. So x equals -4 and x equals 3. Kind of a weird box, but we'll take it. Let's check ourselves.
Did we do it?
Yeah, -4 and 3. -4 and 3.
Boom.
Different method. This is like how a computer would solve it, just because it's so straightforward. It works every single time. The only hard part is doing the math correctly. But compared to this involves problem solving.
Yeah.
This involves this piece right here, which is like thinking critically and testing answers and stuff. And this is literally a procedure that
Just gonna make it too straight.
you just do it, right? It's just easy. But memorizing the formula often throws students through a loop.
Yeah.
So let me do this for you. I'm going to take...
I remember doing this in summer school and I actually liked doing it with that formula.
Well, there you go. Let's do it again. So we'll copy. Oh, you can change the color. I was going to submit a ticket to them saying, hey, you guys should be able to change the color when you highlight things. I just didn't explore enough. All right. So we'll keep that. Go away. Kind of keep this up in the corner. I don't know why I put it there. Let's give you one more problem. In fact, let's give you another problem we've done. Just so we know. Okay, so x squared minus 3x minus 18. X squared minus 3x minus 18. I'll start in black. Y equals x squared. And our goal is to find the solutions, aka the zeros, aka where does y equals 0. Those are all different terms we use to describe the same thing.
When it turned to a positive, would it still be negative?
A negative would be a positive. Yep.
Negative 3 squared would be negative 6. No, it would be negative 9.
Negative, yes. Here, let me toss one thing out here real quick, just because this is a common mistake here. When you do negative 3 squared would actually be negative 9. However, negative 3, when you put it in for b, kind of goes in parentheses. Which this is actually equal to negative 3 times negative 3.
So negative.
So you get a 9, but it's a negative times a negative, right? Yeah. In this case, your negative is waiting for you to multiply the 3 by itself. Mm-hmm. In this case, the negative is going to be multiplied by itself twice. So we can get rid of that. But yeah,
But it is negative 9.
Your answer in this case, we're plugging the negative 3 in for b. So we're doing negative 3 times negative 3. Oh. So it would be 9. I have to change it to purple. I stole your color on accident.
Times negative 18.
Yeah, 4 times negative 18. Could try it by hand. You could do 4 times 20.
No, 78.
Very close. 72. You only subtracted 1 2 from it. You actually have to subtract 4 2s from the 80.
So 72.
72. Yep. And just remember, it's negative. You can have the negative there, but if you put this negative there, then you need to make sure to keep this negative on the 72. The moral of the story, what's a negative times a negative?
A positive.
Positive. So that can just be 9 plus 72.
How do you do 81 divided by 2? No, you don't do that. Jeez.
That was weird. I've never seen
Oh boy.
that. I believe in you.
Here we go. Got it back. Oh. So you do 81 divided by 2.
What is that symbol again?
81? Oh,
That's the inside root. Square root, right? It's
so 9.
We're forgetting some information that we had here. Yeah. X is going to be equal to the whole equation.
X equals 3.
3 plus yeah, exactly.
9.
Yeah, and then just the numbers are over 2. not like the x over here. Exactly, perfect.
And then, don't we do the same? Wait. Oh. So x equals 3 minus 9 over 2.
Mm-hmm.
Do this over here. X equals 3 plus 9 over 2. I forgot what to do now.
Now, this is just throwback to 4th grade math. 3 minus 9 divided by 2.
Three minus 9 is negative 6.
That sounds right to me.
Negative 3.
Yep. If we each have $3 of debt, then collectively we have $6 of debt, which is like the opposite direction of that. Cool. So maybe in this, like, yeah, go in this age, go check your answer if you want, or if you want to write it down. Pretty cool, huh? Cool. Factoring.
Wait, then do I write x equals 6 and x equals negative 3?
Yeah, exactly. Cool.
All over the place.
That's okay. So we have the live, you don't have to just post the picture, we have the live creation of it recorded so you can kind of follow a little easier. But again, factoring and quadratic formula both accomplish the same thing. They help you solve for your zeros or your solutions, right? Factored form, you can write something in factored form if you want without solving for the zeros. But its whole purpose, the reason it's so helpful, is to quickly find the zeros.
Yeah.
Because again, that power of having the factors multiplied by each other, you just need one of them to be 0, and voila, the whole thing smushes. So factored form is helpful if you can get to it, but when you can't get to it, and maybe I'll show you a quick example of when you can't get to it, you just need quadratic formula, which is like the hard-coded process that definitely will work every time.
Yeah.
Sometimes when you can't factor, we won't actually do this problem, but let's say you have a problem that looks like this. Okay, quickly, 2 numbers that multiply to 36.5 and add a negative 14.2.
No idea.
I mean, they don't really. They exist. They're the 2 answers we'll get, but the 2 answers...
7.1.
That's probably a fine guess, right? 7 times 7 is almost 36. Yeah. Anyway, it's going to be, our answers are going to be something like 5-ish and 7-ish, or in somewhere in between there. But the moral of the story is I could very quickly just do this, and this is where you'll get after you practice this a little more. I'm not going to actually solve the problem out, but show you how fast it can be written. Whip my calculator out, type it in, boom, gets me answers, right?